Okay, so let's talk about multiplication of polynomials. We've recently talked about multiplying monomials and addition and subtraction of polynomials. We're going to use those concepts to go to the next step, which is multiplication of polynomials. Now, many times we're going to use the distributive law. In fact, every time we're probably going to use that. And what we have here is a monomial times another polynomial. In this particular case, we have a monomial times a polynomial. We need to distribute this in to each of the terms. Now, x cubed times x squared is the first one. Then we have a positive 3x times x cubed. And we have a negative 7 times x cubed. All right, if we recall in the last section, we talked about how to multiply these two monomials together. You simply add the exponents. So 3 plus 2 here, that's 5. So this is x to the 5th, because x cubed times x squared is x to the 5th. Here we have 3x, which this is like x to the 1, times an x cubed. Adding the exponents for the x's, we get 4. So this is plus 3x to the 4th. And here, we just get minus 7x cubed. And if we notice, there's nothing more we can do. We can't combine these. They're not like terms. So that's all you have to do when it comes to multiplying a monomial times a polynomial. Okay, let's now talk about multiplying two polynomials together. What we'll have to do in this case, if you notice, we have something with two terms on the left side here, and on this side we have 3 terms. What we need to do is make sure that we get the first term multiplied to each thing, as well as the last term needs to be multiplied to each thing. Let's break this down and make sure we break it down into a simpler problem. Well, first let's write it like this. So I need 2x times everything. And then I need a minus 3 times everything. If you notice, if I cover this up, this looks like what we just did a second ago in the last example. And same, if I come over here and cover this up, this is the same thing that we did in the last example as well. So all we're doing is building on what we're learning to get to more complex problems. So let's start with this side here. What we have to do, just as before, we distribute this to each term. So now we get 2x times x squared. This is an x to the 1, and this times an x squared. We add the exponents, that gives us 2x cubed. Now 2x times 6x. 2 times 6 is 12. And x times x is x squared. 2x times negative 2. Well, 2 times negative 2 is negative 4. And the x comes along for the ride. So this is multiplied, is the result from doing the distributing of this particular situation over here. Now let's do this one over here. We got to take the minus 3 and distribute it to all of these terms as well. So negative 3 times x squared, that's just negative 3x squared. Negative 3 times 6x. Negative 3 times 6 is negative 18. And so the x comes with it because there's no x is being multiplied on this particular term. And then we have a negative 3 times a negative 2. And that's going to give us positive 6. Okay? So now that we've broken the problem down from here into 2 of the problems that we saw before, once we did this, we've now broken it down into something we saw in the first section, which was addition and subtraction. So we have to combine like terms here. Let's start with this one. It's the only x cubed I see available here. So I'm just going to bring that one down. Let's look at x squareds. I got a 12x squared minus 3x squared. Well, 12 minus 3 is just 9, so it's positive 9x squared. Let's look at the x's. Minus 4 here, minus 18 here. Well, minus 4 minus 18, that's negative 22, so that's minus 22x. And then all that's left is a 6, but that's by itself. There's nothing to combine with that, so I can just bring that down. Okay, and this is how you solve problems where you're multiplying two polynomials. No matter how long this polynomial is, you'll do the same process. Each term over here needs to be multiplied by this whole polynomial individually. So now let's move on. Let's move on to multiplying two binomials. That's what we'll see in this next example. Okay, so multiplying two binomials here, we're going to use a technique called FOIL. Now, FOIL stands for first, outer, inner, last. The first two terms, you can see there's two groups here. There's this group of 2y plus 7, and this group, 3y minus 2. We're going to take the first two terms and multiply them together. So here's the first two terms. So 2y times 3y. Those are the first two terms. Okay, now we take the outside term. Now we look at it as this whole thing. These two are the ones on the outside. All right, so I have a negative 2, and I have a, well, let's do this. I have a 2y and a negative 2. Now let's look at the inner terms, which are the ones on the inside here. So we hit this one. We did the first and the outer. Now we're going to do the inner and the last. Okay, that's the kind of order we're going to do it in. So let's now get to the inner. These two are the inners. Plus 7 times 3y. And finally, we have the outside two terms, which is plus 7 times negative 2. Running out of space here. 7 times negative 2. Let's simplify this. This over here gives us 6y squared. And this came from the fact that I'm just adding the two ones that are here. Y to the 1 times y to the 1. You add the ones, you get y squared, and this comes from 3 times 2. All right, I got a 2y minus a 2. That gives me negative 4y. 7 times 3y is 21y. 7 times negative 2 is negative 14. Now we need to combine whatever's left at this point. We have to make sure we can't combine anything. In this case, we can. We can combine these two y's. They're like terms. So let's do that. 6y squared. This negative 4 plus 21 is positive 17. And I'm left with minus 14 here. And this is how you would multiply some binomials. Let's take a look at a few more examples of this to get a better understanding. All right, here's a couple more examples of multiplying some binomials together. Let's look at the first one. The first one says x plus 3 squared. A lot of students make the mistake to just to square this and square that and say that that's x squared plus 9. That's not how you want to do a problem like this. The best way to do it is to write it out like this. Because remember, when you're squaring something, you're multiplying that thing by itself again. So like 4 squared is 4 times 4. So x plus 3 squared is x plus 3 times x plus 3. Always remember to do that. Let's use the FOIL expansion to multiply this out. The first two terms, we get x times x, which is x squared. And then we got to do the outer terms, that's the O, the two outsides, x times 3, that's plus 3x. The inside terms is x plus 3, that's plus 3x. And the last two terms, this is 3 times 3, which is 9. And we can simplify this a little farther by combining these like terms here. This gives us 6x plus 9. And this 6x, of course, comes from the fact that I just added those two terms that were like terms in the middle. 3 plus 3 being 6. Let's look at this one now. Notice I picked these problems. They're similar, but this one has a minus sign in it. Let's look at what happens in this case doing the FOIL. The first two terms, x times x, that's just x squared. The outside terms, x times negative 3, that's negative 3x. The inside terms, which are 3 times x, so that's just 3x positive this time. And the two last terms here, 3 times negative 3, that's a negative 9. Okay? Now look what happens when we try to combine here. Well, negative 3x plus 3x, that just adds up to be 0. So these kind of cancel each other out here, and we're left with x squared minus 9. Okay, now there are some general formulas for some of these two in particular, which we'll go over in a little bit. But for now, this is how you would do multiplication of two binomials using the FOIL expansion. In the next section, there will be a cover on integer exponents, so that will be coming up.